Today's lesson is on irrational numbers. We've been working with rational numbers, and now we're moving on to a new kind of number, irrational. The definition says that it is a number that cannot be written in the form a over b. So in other words, there are numbers that in no way can be written as a fraction. So for this to be true, you have to start out, it's a decimal, but it's a specific kind of decimal, because other decimals can be written as a fraction. This type of decimal has to be non-terminating, meaning it will never end. It goes on forever, but it also has to be non-repeating. So just keep that in mind. 0.33 repeating goes on and on forever, but that's rational because it can be written as 1/3. There's a repeating pattern to it. So let's look at what an irrational number looks like. So an irrational number, I'm just going to make one up here, 0.212446831722, and let's say it goes on and on and on forever. So this would be non-terminating because the decimal keeps going and there's no repeating pattern to it, so it is irrational. There's no way to write it as a fraction. And then two other famous examples would be the square root of 2 or pi, because we all know pi, 3.14159, and that keeps going on and on forever, and there's no repetition to the decimal, so it is irrational. Now let's compare rational and irrational numbers a little more. So real numbers, which is just all the numbers that you currently know, are broken up into either rational or irrational, and then more specifically, rational numbers can also be integers. So some examples of some rational numbers, we have 1/2 or 0.125 or 0.588, and that repeats, or -7/9, all different examples. And then we also have integers, -5, 2, 7, the square root of 36, because the square root of 36 equals 6. So all of these integers, remember, are also rational because they can all be written as a fraction, like 7/1. And now, today's lesson, we're moving on to irrational numbers. So I already gave you a couple examples, pi, square root of 2, and there's actually a lot of them end up being square roots, but not always. But the key thing is, if you take the square root of a number and look at the decimal, the square root of 3 is 1.73205008, and this goes on and on forever. It is a non-terminating decimal, and it doesn't repeat. So that is why it is irrational. Follows that definition. Now I'm just going to give you some examples of numbers, and we have to decide, is it rational or is it irrational? And if it's rational, is it also an integer or not? And then explain why. We're going to do 6 examples. I think we'll do 3 together, and then you can try 3 on your own. Our first example is -7.34. And let's look at the decimal. The decimal is only 2 places, so because our decimal terminates or stops, that means that it is rational. So let's just name it rational and then explain why it's rational, because the decimal stops. It terminates. Now let's look at the square root of 17. You can take the square root of 17 on your calculator and look at the decimal. The decimal never stops. It's non-terminating. It goes on forever. And there's also no repetition to that decimal, so this one is irrational. And now the next example, let's look at the square root of 64. In this case, the square root of 64 is 8. And 8 is an integer, and all integers are rational. So another explanation, 8 can be written as a fraction because you can write 8 over 1 or 16 over 2, which makes it rational. Here are 3 more examples. Why don't you pause the video, write them down, and see if you can figure out which ones are irrational or rational. And then you can check your answer. Here are the answers. On the first one, the decimal goes on and on forever, but it's repeating, so it's rational. Second one, well, it's written as a fraction, therefore it's rational. And then the last one, because it has pi, it means it's irrational because the decimal is non-repeating and non-terminating. So there's your full lesson on irrational numbers. Good luck!